Okay, this was the problem I was speaking. I just glanced by. The problem is having two tables. Table number 1 give you generator information and all the buses in the system. Table number 2 give you connectivity information. Base is 100. Then that information is used to draw a simple rough sketch of single line diagram. Then mention all those values on that. Then use the base of 100 and understand it is in impedance form of connectivity. Convert it to in admittance. That was what I was saying. Hope this is visible now. I am sliding the screen. Visible to you?
Yes, sir.
Fine. Thank you then. And now I'll be comfort. Okay. The same problem. When I convert the transmission line data impedance form to admittance, each line will have these values. So this material is already shared with you. If you find any difficulty, you can contact me anytime. I can definitely convey you with respect to the problem. No worry at all. Okay. So same material I'll be using you to give you insight of all these problems, how you should view them. Once I convey you a gist or glimpses of it, you will be confident to identify each problem with typicalness. Okay. So all the information in the form of impedance, what was given, converted to admittance and put on the line. And all the values of powers were put in the form of PU. 200 megawatt of bus 3 is put as 2 PU. Voltage is given as 1.04. And at bus number 2, 300 MW was there. 300 divided by 100 becomes 3 PU. And 150 MVAR was there. It would become 1.5 PU. Just to remember that, you can go to the next interaction where I will be using PG minus PD as a net power situation at bus 2. QG minus QD as net power reactive situation at bus 2 for the calculation of voltages, etc. Okay. This is how this step can be done. This, as per me, stand as a first step in solving the GSLF problem. Given you a table of information, either in the form of graphical single line diagram or information in the form of table, concluding this way. This is the first step as per me. Then you can see here how the author has presented at bus 3. Qmax, Qmean were given. So he has taken 10 divided by 100, 0.1, 50 divided by 100, 0.2. They were Qmean, Qmax values. And that was a voltage controlled bus. What was the scheduled voltage for that bus? 1.04. So he assumed, let V30 voltage of the bus 3 initial estimate 0 be same scheduled value. Yesterday we were discussing. It's quite comfortable. If you use the scheduled value of the generator bus as an initial guess, it will reduce the work burden. If you use 1 angle 0, nothing wrong. But the expectation is if I use a scheduled value, computational burden and time, you will have little relief. In this regard, he mentioned at bus 3, I will be taking this consideration. Then my step goes to V2 of 0. What is V2 of 0? Voltage estimate of bus 2 initially. V2 0 is because it is a load bus. Load bus voltage I need to calculate. I start with 1 angle 0 or 1 plus J0 because it is called as a flat start. Then I look into the admittance form because I require Y22, Y33, 12, 21, 23. All these admittances I require to solve my numerical problem. Hence, my necessity is to form Y bus. So, Y bus is nothing but system admittance bus. From this observation, I have 3 buses in the system. So, Y bus shall be 3 cross 3 by visual instruction itself. So, if I go to Y11, the diagonal element of bus Y bus 11 is sum of the admittances of the line going from 1 to 2 and 1 to 3. If you add 8.823, I am taking them in a complex form, real terms. 8.8235 plus 11.236, it results to 20.0595. And reactive terms, minus 14.706 minus 17.98, it results to minus 32.667. It is nothing but sum of the admittances of the radiating line from bus 1 to neighbor is called as Y11. What is Y12? First row, second column in this matrix. It is the negative of the admittance of the line connected between 1 and 2. Nothing but 8.8235 minus J 14.706 is put inside with the negative outside the bracket. Can you see that? It is a negative of the elemental admittance between 1 and 2. The same principle you can see at bus number element number 1 to 3. What is 1 to 3? 11.236 minus j 17.98 inside the bracket. Outside there is 1 minus, nothing but negative of the y13 is put here. This is about first row. The same thing should be continued for row number 2 for bus 2, row number 3 for bus 3. If I want to convey you, what is y22 for me? Y22 is addition of the admittance of this 1 to 2 line, 8.8235 with 40, it becomes 48.8235. You can see here 2 cross 2 in the matrix, and the reactive term minus j 14.706 and 20, it becomes minus j 34.706. You can visualize very easily. That is 2 cross 2. What is 2 cross 1? First element in the second row. That is same as 1 cross 2. Copy paste. What is 2 cross 3? 2 to 3 element. It is 40 minus j 20. Whose negative is put over there. This way, by instruction method, if you could continue within 2 to 3 minutes of time, you are able to form Y bus by instruction method. Hope you all are able to do this Y bus by instruction method. Given your problem either single line diagram or in the form of table, you can reach this. Once you reach, you are in the right position to calculate unknowns. So what are unknowns for me? Slack bus power I should not touch. It should be done at the end of the convergence. Hence my immediate bus is bus number 2. Bus number 2 is load by type. If it is PQ are given, what are unknown? V and delta are unknown. So for me that stand as my first calculation. You can look into iteration number 1. I am moving the slide. At iteration number 1 for bus PQ. So V must be calculated since P and Q are specified. Now look into this. What is this given? V2 of 1. Calculated value of the bus voltage 2 at the end of iteration 1. V2 1 is equal to what? I recall back in the presentation on board what I did. 1 divided by y22 outside a square bracket. I was speaking 1 divided by y22 inside a square bracket. What I pronounce? P2 minus jQ2 over V2 0 conjugate minus the capital Y, Y21 V1, Y23 V2, Y23 V3, Y24 V4 like that. Now, can you observe this? Yesterday in the session, we have seen one textbook problem where instead of using capital terminology of admittances, author referred lowercase terminology. What was the meaning of that? Elemental admittance. When I use elemental admittance, the minus which I am pronouncing, which become plus at that time, which what is noticed here. So it is V2 of 1 where whole large divide symbol means a horizontal line below which you have Y21, Y23. What this refers? Elemental data connected from bus 2 to 1, bus 2 to 3, nothing but capital Y22. Can you see that notation I have given there? Nothing but capital Y22, which is at the grand denominator. In the bracket, which was supposed to be P2 minus jQ2 divided by V2 0 conjugate. Here I should have minus Y21, but it is lowercase y21, nothing but elemental admittance. Hence it is not to take minus, directly drag and drop from the elemental information. And V1, what is V1? Slack bus voltage. Can you see over here? Yesterday I was speaking. V1 0 is never pronounced. V1 1 is not pronounced. Can you see this print? This is a misprint. So because these are the material free of cost, so refer from academic perspective only. Hence, such material when you refer should be very careful. It is V1. What is V1 for you? Slack bus voltage. Slack bus voltage will be constant throughout your solution. It is not having V0, V1, V2 like that. It is V1, that's all. Therefore, no matter, it is slack bus for me. Next, I have connectivity with the 2, 3. How do you come to know how many elements are over here? Particular row number 2 you have to catch. How many elements are present in the row number 2? That many elements appear. I am quite sure looking to this, there are 3 elements. One is the bigger element, Y22. Second is Y21. The third is Y23. So all these things you can get from that. Then I substitute V1. Y23 means V3 0. I did not calculate third bus voltage still because I am at second bus. Hence it is initial estimate. So you can see a note written here. Note Y21, Y23 are not are actual admittances and not from Y bus. Hence, they are positive. I wrote a comment over there. So, therefore, you must be careful when you refer such solutions from different books. Next is to substitute. What is your P2 value here? I am working upon load bus. So, I just move the screen up and come back. P2 means what? PG minus PD. What is Q2 for you? QG minus QD. So, I go back and come. I expect here no generation at the bus number 2. Only demand is there. 0 minus 300 megawatt divided by 100, 3 PU. 0 minus 3 is minus 3. Minus, as it is minus. For Q2, QG is 0. 0 minus 1.5. That is minus 1.5. Minus and this minus become plus. It becomes minus 3 plus J 1.5 as I was speaking in the first presentation. Can you see over here? Here. This one. So this will not worry. This kind of presentation by the author will not consider. We will just consider P and Q. Ourselves will take the consideration what we have to do. Therefore, it is minus 3 plus J 1.5 divided by what the variable I am working? V2 of 1. Solution of bus 2 voltage at the end of iteration 1, whose initial estimate is V2 0 conjugate, which is 1 plus J0, nothing but 1 minus J0 for conjugate. And wherever there was a plus, which I was pronouncing was a minus because of capital terminology, here is a lowercase. Will not worry. It is Y21 product with slack bus voltage plus Y23 40 minus J20 into V30. What is V30? V3, what is V3 for you? V3, I'll go back here. What is V3 for you? It's a generator. Otherwise, if it is a flat start for a load bus, I would have taken it as 1 angle 0. But it is advisable for me, if there is a generator bus, scheduled voltage of the generator, if I utilize as an initial guess, it is quite comfortable. The same thing is used here. This Y23 into V30. So, divided by Y22, nothing but diagonal element of Y bus. So, this if I take, it will be leading to me solution of voltage of bus 2 at the end of iteration number 1. So, I was speaking to you all, it is not that easy. Complex products are here. Carefully you have to resolve. You have to confirm yourself, your mathematical accuracy at least once with the calculator. Then you will be comfortable what the operations you are performing with the calculator might turn out good, because the BOD-MOS kind of rule, when it comes to the application, you must be careful what to divide, when to divide, what to add, when to subtract. So those all things must be taken care. My sincere request is, once we have to do numerically with the calculator, with this paper or with this print, then you will be comfortable. Then you can see the simplified work of that is V2 of 1 stand here as 0.9899 minus J 0.0109 in rectangular format. The same thing when I put to polar format, this is the value. So it is called magnitude of voltage solution of bus 2, angle of that bus. It is called V2 delta 2. So I have reached one end of the problem about bus 2. What is bus 3 for me? Bus 3 is generator bus. I take you back. Bus 3 is generator bus. At this bus, what are all things given to me? P and V are given. What is my destination over here? Q and delta. So before I calculate V3 of 1, I must check Q3 of 1. Whether this generator is able to inject required reactive power to the system. Q31, I have to check. Then that Q31, I have to compare with the limits, boundaries with the 0.1 and 0.5 as per this problem. If it is within the range, yes, this generator remain as a generator. I should calculate V3 of 1 later. In that regard, I move here. So you must see here. Bus 3, Q3, 1. You can see here. Q3, 1 has to be calculated. What is the equation I will be using? Minus of imaginary part of complex power at bus 3. There are 3 different methods to do it. So this is one method. You can refer my note here. Refer the equation written at the footer. I just applied it. What is the equation I wrote here? Qi r plus 1 equal to minus of imaginary part of entire term in the flower bracket. Vi 0 conjugate summation k 1 to I minus 1 yik vk r plus 1 plus the one which is k. No matter whether you use this equation to get your answer or if you use this equation which is shown you. What is this equation? What is 2, 3 for you? Reactive power. Where it is available? At bus 3. What is the complex power at bus 3? S3. What is S3 for you? P3 plus JQ3. If I take the conjugate of SI, S3 conjugate, what will refer to? P3 minus JQ3. Conjugate of complex power at bus 3, which is P3 minus JQ3, which can be written in terms of V3 I and conjugate of entire thing. It is nothing but conjugate of V3 and I of bus 3. What is bus 3 current? Bus 3 current is the current flowing from bus 3 to 1, I31. Bus 3 to bus 2, I32. If I calculate them and get the value of I31, I32, add them, that become current I3. Then if I use it with the V3, I will be getting the complex power at a particular bus 3 and separate real and reactive power, take only reactive power. That's one thing. Otherwise, you can see over here, I have just made some minus and plus corrections over here for the easiness. What is that? Minus of imaginary part of V3 conjugate, Vi conjugate, I am taking. Vi conjugate, whose conjugate become conjugate of voltage, straight current. Current is not taken conjugate at that time. Therefore, it is V30 into current I want. Where all current is flowing? V3 to V1. You can see over here Y31 and there is a Y31 V1. It is simply, if I pronounce this in oral terms, how this calculation comes out. What is the current going from bus 3 to bus 1? V3 minus V1 into Y31. In my first principle by nodal analysis, what is the current flowing from bus 3 to bus 1? V3 minus V1 into Y31. It is there in this line. You need not worry. If you really want, you can take like this only. V3 0 conjugate. Inside a bracket, I want current flowing from 3 to 1. V3 minus V1 into Y31 plus current flowing from bus 3 to bus 2. What is that? V3 minus V2 into Y32. If I take this product, it is the product what is mentioned inside the square bracket over. I am just pointing the mouse cursor here. This is what the cursor, which is square bracket. This is actually the current. The current means product of V and Y. Voltage and admittance representative current. So it is being split. It is written in as four terms. Term 1, term 2, term 3, term 4. If I really consider V3 minus V1, Y31 common, it become one term. If I consider V3 minus V2, Y32 outside, automatically these four terms become gathered as two terms, which represent me I31, I32 for me. Whose product with V3 0 conjugate, if I refer, that represent me complex power situation at bus number 3. Of that, only reactive term is my interest. Hence, it is outside minus imaginary part of entire operation of complex power. And you just see the substitution. What is the substitution for V30? What is V30 for you? Initial estimate of bus number 3. You can see that 1.04 is given because it is called voltage of a particular bus number 3. Then you have what is V30 here? Once again 1.04. Again, what is V2 for you? V2 is just now calculated. What is V2 for you? 0.9899 minus J 0.0109. I mean, even I need not look that serious about this. Whatever the term I was just pronouncing, which is V30 conjugate into I3. I3, if I calculate separately in one line, take that complex value, multiply with V30, which is 1.04 plus J0 conjugate. If I product it, I will be surely landing the final answer of what? The last line you can see, Q3 of 1 equal to minus imaginary inside a square bracket 2.0772 minus j 0.2147. So these many additional lines have been mentioned by the author in some systematic way that can be taken as a granted by just taking the term V30 conjugate into I3 product. I3 how I get? V3 minus V1 Y31, V3 minus V2 into V20. If I operate, I'll be able to get this product directly as this line, final line, Q3 of 1 equal to minus imaginary inside a square bracket 2.0772 minus j 0.2147 bracket complete. From this, what is my pick? Only the second term, imaginary part. What is the imaginary part here? Minus j 0.2147. As I have a minus outside, this minus gets cancelled. The answer what I pick from this line is only 0.2147 pu. Can you see over here? Only to get this was my whole work of Q31. So you can utilize the skill and technique how best I can reach Q3 and I can get this second term of particular complex power. This is the term I have to compare with min and max value of bus 3. What was the min value of QG? 10 was given, divided by 100, it was 0.1. Is it less than 0.1 or more than 0.1? More than 0.1. Then definitely, is it less than the particular value of 50? Yes, definitely. And this is the valid value in the range 0.1 to 0.5. Hence, this generator can really maintain the voltage 1.04 is the meaning by this calculation. By chance, this value went very, very larger than 0.5. Then it is to say this generator cannot maintain 1.04 pu voltage on its terminals. Hence, it is switching into load type. So that was what the situation. But naturally in this problem, we haven't faced that problem because computed reactive power of bus 3 stood 0.2147, which is very well within 0.1 and 0.5. Hence the next step, we can now calculate V3. What is V3 for me? Computed value of voltage of generator bus at the end of iteration number 1. There is no change in pattern, exactly same. P3 minus JQ3 over V30 conjugate and plus lowercase y31 V1 plus lowercase y32 V2 over y33, which is y31 plus lowercase y32. It is exactly same as what the equation we obtained on first day of introduction of load flow basic equation. It is same. Now I have to check what is that I have to substitute in the P position, P schedule. What is the PV value given here? P value of this generator is given as 200 MW divided by 100. It is 2 PU. 2 is the position holder at P3 schedule. What about Q3 schedule? Q3 schedule is the value which just now you calculated as 0.2147. After checking its limits, this is the best fit value to be located in the position Q3 schedule. Now you must look into, my friends, if you go wrong with the Q3 calculation in this problem, your V3 calculation is sure to go wrong. You have just gone out of the requirement. Therefore, calculation of reactive power for a PV buses is very essential and important step. Once that is justified properly, value of voltage computed for that bus will be in the range. Otherwise, we may go wrong. Therefore, see to that once I calculate V3 of 1, what is P3? Schedule in the problem. What is Q3? Calculated in the sequence. After checking, it is to be substituted, divided by initial estimate of bus voltage. Because it's a PV bus, initial estimate works out as 1.04 only, whose conjugate, and V1, lag bus voltage. What is V2 of 1? Just now, previous step was bus 2's calculation, whose voltage 0.9899, whatever we got, we have to obtain. Now I'll move to the next page. You will see substitution of these things. Can you see over here? P2, nothing but P3, 200 megawatt divided by 100. PG minus PD. PG minus PD. PG is plus, PD is not there, it is plus. Minus J, QG minus QD. QG is 0.2147. Q demand is not there, and it is 0.2147 only. You must be very careful. The numerator term calculation of a PV bus, numerator term calculation of PQ bus differ a little. You must be very careful. Looking to the value only, I will say it's the PV bus. It is a minus at the first term. It is the load bus only. That I can see. Provided straightaway load. If there is a generator and load, it could matter your calculation. But this way, you must know. Divided by V30 conjugate plus Y31. I mean, it is V3 into Y31. V30 into Y3. Not V30. Is it V1? Yes, it is V1. 1.06 is called slack bus voltage. It is Y31 element. I will show back. Y31. Y31. Is it right? 11.236 minus J 17.9. It is called as 1, 3, same as 3, 1. That is being referred here. Correct? 11.236 minus 17.9 is called as Y31. Y31 into V1. Similarly, Y32 V2. V2 means computed voltage of second bus in the previous step divided by Y33. What is Y33? Diagonal element of Y bus. If I solve this, I will be getting complex answers. But this is not the final answer of a generator bus. You all very clearly know, for a generator bus, V is given in the problem. That is the answer. 1.04 is given. That must be your answer. Then what is the angle? Angle is the one which I have to calculate from this. So it is a rectangular form. Convert this to polar form. When you convert this to polar form, you will have magnitude and angle. So magnitude you replace by 1.0. Can you see in the final mark here? Hold VI specified and use calculate delta. I wrote a comment here. You don't worry about this calculation. Directly this answer, what you got, you convert to polar. Once you convert to polar, you will have magnitude and angle. Angle is the one you have to carry forward. Magnitude you have to reject and replace it by scheduled of the particular bus. 1.04 was given in the problem. That has to come as a final answer. And angle what you computed from current step has to be carried forward. This is the change in PV bus. So this has to be done. Then if at all you require to go for iteration 2, 3, 4, this book is presenting you more than 2 iterations. So I put a dotted line here. So line stop here. This is not to go further. Only one step is required for us in the curricular. After having computed them, you may be required to calculate. Go to slack bus and line flow calculations directly. I wrote an arrow here. It means to say, in the examination, as per our VTU sequence, one iteration is mandate. After one iteration, if author expects you to calculate what is the line flow, what are the line losses, and what is the power delivered by slack bus, you need to follow respective sequences that you did yesterday. So I move to the next line directly. This iteration 2 I skip. Okay, I come to here. The process is continued till your convergence. But for me, only one iteration is the convergence. Once if I compute, what is known to me? Use V2 of 1, V3 of 1 in this position. What is the printed values here? What are the printed values? Printed values are end of second iteration in the book. For me to convey you, one iteration is sufficient. Therefore, I say instead of these values, take the previously what we just discussed. End of iteration 1, we got V2, V3. Those things you place in this position, in the rectangular as well as in polar. Use them for your calculation of complex power supplied by slack bus. What is that? S1 conjugate. S1 nothing but bus number 1. S1 nothing but complex power at bus number 1. Conjugate of it is active power minus reactive power separation. How you would do? Again, you will see a large bracket here. The square bracket term is nothing but current flowing from bus 1 to 2, bus 1 to 3. You can see here. V1 is there, V2 is there. V1 is there, V3 is there. Likewise, This process is one typical way of writing it. So what I can remember, V1 I know at this time, which is given. I1 I don't know. What is I1? Bus current 1. How do I calculate I1? I calculate in parts. How is that calculation in parts? 1 to 2. What is the current flowing? V1 minus V2 into Y12. If I operate, I will be able to get I12. If I want to get I13, I should use V1 minus V3 into Y13. I will get I13 current. Add those two. I12 plus I13 result you capital I1 at the bus number 1. Use that in the calculation. What is that? Complex power conjugate at S1. Nothing but bus 1 equal to V1 conjugate into I1. V1 conjugate into I1. If I take a product and separate them, you can see over here 1.1093 minus J 1.13621 is the answer obtained by the author using second iteration data. I am very clear to mention you. This data, what I am pronouncing, is the data obtained by the author by substituting V2, V3 as in the printout here. End of the second iteration, those data were obtained, those were used inside and got here. And he calculated it. Similarly, what is bus 3 calculation? Bus 3 calculation is also complex power at bus 3. V3, I3 conjugate, which is called injected power from bus 3. We calculate. Then these are called as per unit values. To get real value, what you have to do? Multiply it by 100. If I multiply by 100, it becomes 200. If I multiply it by 100, it becomes 50 for me. So in this way, I have to calculate these things reality. So these values were used by the author, which is at the end of the iteration to what he obtained. For me, my suggestion to you all is, in the place of V2 of 2, V3 of 2, use our calculated value in the previous page, V2 of 1, V3 of 1, in this marked position which I am moving the pointer in this position. Substitute them in this way and get your real values. That job comes to be the power delivered by slack bus and power delivered by S3 or nothing but bus 3. Then line flows. We are very familiar now. What is the complex power flowing from S1 to 2? It is first term say voltage, together say current. It is V1 I12 conjugate. V1 I12 conjugate say complex power flowing from bus 1 to 2. For that I12, what is I12? V1 minus V2 into I12. So I21 is exactly opposite to that. So this is the first principle what we learned. So using these equations, we can calculate forward flow, reverse flow. Then I can add forward and reverse flows to get line loss. So my friends, look to me. These were the calculations printed to you based on iteration number 2 data. These are not matching to our requirement. Hence, I mentioned over here. So use our V2 of 1, V3 of 1 in the previous page what we discussed in the respective position and try to work out similar to this, so that end of the iteration 1, what is that complex power supplied by the slack bus, what are the transmission line power flows, what are the transmission line losses, I can determine. This is how you have to look the problem which is already solved in a problem or a resource available with the need how I should understand. This is how we can do it. Similarly, you can see line losses, total line losses, we calculate. SL12 forward reverse, SL13 forward reverse, forward like this. So this is how this is an exhaustive work one need to understand. Similarly, I move with a similar. Now I will be moving a little faster because now you got to know. Another bus problem if I have. Can you read these 3 buses are there? First bus is slack bus. V is given, angle is 0. Second bus is generator bus. Earlier problem, second bus was load bus. Third was PV bus. Now second is PV in this. No matter where is PV, where is PQ. For me, it is a sequence. Second is PV. P is given, V is given. Q limits are given. Minus 200 plus 200. That is my requirement. It is given. Done. What is PQ bus? Load bus. What I expect? P and Q. Is it given? It is given. 275 and 120. and voltage is mentioned 1.0. It need not be mentioned. If it is mentioned, well and good. If it is not mentioned, it is our duty to calculate at the PQ bus. Okay. So hence initial guess is given as 1 for me here. Now what is the base of the system? 100. Then I require connection of the system. Look at the table number 2. 1 to 2, 1 to 3 and 2 to 3. We have 1 to 3, 1 to 2, 2 to 3. You have been given resistance and reactance. Half line charging and cap changes I will not consider because it's not important for us right now in this problem. It's not being used also. Okay. R and X. 1 to 3, 1 to 2, 2 to 3 were given to you. Using these data, I have to draw single line diagram first if I require. Then convert this impedance to admittance. You can see how it is being done. Okay. Initially, the first diagram is diagram with the 3 buses with the impedance on that. And impedance is converted to admittance in the next figure. And all the data were given in numerical value 200 megawatt, 275 megawatt, 200 like that. They need to be converted to per unit when I divide it by 100. So therefore, I must check whether problem is put on the paper or on the representation properly or not. It is done. Impedance is converted to admittance. Then this 200 becomes 2 pu. Then here 275 becomes 2.75. 200 becomes 2.0. You will not worry what is this schedule and all. Simply you remember PG, PD concept you should remember. There is no injection, only demand. PD is there. There is no injection of reactive power. QG is not there. QD is there. That's enough for me. I will substitute in the equation very straightforward. So that way I have to convert this data into per unit. It is being noticed. It is being done. That's all. It is being done. Then I'll go ahead. What is my next step? After having this problem visualized to me, my next step is to calculate Y bus of the system. Now I need not spend much time. 3 buses are there. 3 cross 3 is your dimension. Are you able to see in the problem? Yes, it is 3 cross 3. At bus number 1, 1 to 2, 1 to 3, you have a transmission line. You will find all the 3 elements in the row number 1. Similarly, row number 2. Similarly, row number 3. All the elements are connected. 1 to 1, 1 to 1, there is a connection. It means you will find full house matrix. Nothing is 0 over here. So these values need to be justified by you by taking cross check. What is Y11? Addition of 1 to 1 3. Is it there? It must be there. 13.32, 5.88. It lands on 19.2. So it's working good. Like that, numerically you must check. What is Y11? What is Y22? What is Y15? Diagonally at least. Once you check, you will be comfort. Yes, it is working. Then this is the Y bus of the problem. Then once the Y bus is ready, the author has given the scheduled voltage of bus 1 is given, which is a slack bus voltage. Bus 2 is given, it is a generator bus. Bus 3 is a load bus whose value is given 1, which is expected to be a flat start for me. So I will check how to go ahead. To go ahead with the sequence, slack bus I will not touch. I go to bus number 2. What is the type of the bus? PV bus. Once it is a PV bus, what is my process? Instead of computing voltage directly, I have to calculate reactive power ability of that bus. What is the reactive power ability of that bus? Q2 of 1. Can you see over here? Q2 of 1 is to be computed, which is minus imaginary part of complex conjugate of power at bus 2. I again speak here how to calculate complex, because repeatedly if I pronounce to you, you might be comfortable with few calculation, because it is very essential. If you skip and go wrong, I am quite sure entire problem is wrong. How I will tell you? If you are unable to get Q2 properly, your V2 goes wrong. If V2 goes wrong, your V3 sure to go wrong. And if V3 go wrong, line power flows go wrong. If line power flow go wrong, your slack bus power go wrong. I am 99% sure only your Y bus is correct. Hardly you have 2 marks. That's all. Not more than that. That's the reason when you touch numericals, numerical accuracy is always challenging you. Hence, be very attentive to the requirement as per the problems. Therefore, my repeat to you, What is complex power at bus 2? I want separation of complex power into active power, reactive power. From my basic principle, what is complex power? SI, VI, I conjugate. When I want conjugate of a complex power, conjugate of SI, it is having minus in between, P and Q with a minus sign. Therefore, at that time, voltage become a conjugate, current become a straight. It becomes VI conjugate into I. That's all. How is that that will be given to you or computed? In this problem, 1.03 is the voltage given. V2 is known to you. Conjugate of which doesn't make any difference because angle is 0. 1.03 angle 0. Doesn't make any difference whether you take straight or you take a conjugate of it. But what makes a difference is current. What is current I2 for you? I2 you need to know. For that calculation, you have values of V2, V1. V2, V1 minus V2 minus V1 and Y21. V2, V3, because initial estimate you are using. What is initial estimate of V1? Sorry, V3, 1 angle 0, which is V2 minus V3 into Y23. I will be able to get both the current rushing out from the bus number 2. No matter whether it is towards the bus or away from bus, I am not worried. I am worried current leaving bus 2, V2 minus V1. That's enough for me. If it is plus value comes out, it's going out. It comes minus, it is bus towards 2. So I will not worry about that. I will not check also. It is automatically taken care in the calculation. Therefore, V2 minus V1 into Y21 and V2 minus V3 into Y23 give me the current total rushing out of the bus 2 into that numerical value with voltage of bus 2 conjugate. Give me complex power total, active and reactive. Reject that active, only reactive you pick. That reactive power where minus is already there, minus of imaginary part of the reactive power inside the bracket. So that is my requirement. Hence, you just get into this. This is being done. So, minus of imaginary part of complex power conjugate at bus 2, whose second term is of my interest. Now, can you see how intelligently author is making you to involve? In the first problem, author substituted the value, simplified it by 4 or 5 lines and made you aware what should be done. In this second problem, he is making you to do it. So, it is how you have to practice how to calculate Q value because it is very essential. So, at the end of substitution of respective values and admittances, the value turns to be rectangular like this, 1.0430 minus J 1.5819. Of this, minus imaginary part is of my interest, which is 1.5819. Is picked out as my Q calculated at bus 2. This is how you must apply the fundamental concept carefully. So 1.589 is the computed value of reactive power at bus 2. Now what is my next step? I have to check this with limit min, limit max. What were the limits given in the problem? If you don't remember, it is minus 200 and plus 200. Divided by the base value 100. It becomes minus 2 plus 2. Minus 2 is the lower limit, plus 2 is the upper limit. Is this 1.5819 fall within this? Yes. Then this generator is capable of maintaining the scheduled voltage, whatever is pronounced. Else, it will be switched as load bus. So therefore, this computed value is valid. It is shown here. Okay. I just move. Okay. Now, use calculated Q2 in this position. P2, what is given in the problem, initial estimate and connectivity, Y21, 2 to 1 voltage, 1 voltage, Y2 to 3, third bus voltage initial, divided by capital Y22, it's called diagonal value of the second row, second column. Then when I substitute all these values, it is called P2. May I know what is P2 here? P2, if you would like to know. Q2 you know, 1.5189. What is P2? You might have forgot. I go back and tell you. What is P2 for you? 2. 2 minus 1.5819 should be the position of the numerator over here, which I am moving the mouse cursor. 2 1.5819 divided by V20 conjugate, 1.04 conjugate, nothing but 1.04 only, plus the admittance, not the admittances from the elemental, from the Y bus. It is a simple element, plus simple element Y21 into V1. V1 is slack bus voltage. Whatever is mentioned directly. And 2, 3, element between 2 and 3 into bus 3 voltage, which is 1 angle 0, divided by diagonal element. If I take a product, I will be landing with the answer 1.0359 plus J 0.01546. Now these extra calculation what the author has done, I personally request, stop, don't do, read my comment, hold, VI specified and calculated delta I. Don't do extra calculation. With this rectangular value, simply convert it to polar. Convert it to polar, reject the magnitude, retain the angle. When I reject the magnitude, what should be placed? VI specified. What is specified in this bus? You can see here, 1.03. When you convert it to polar, whatever the answer comes as a magnitude, reject it. Hold it at 1.03. And angle, whatever comes, you contain that. You retain that. That's what is the answer here. Hold, VI specified and calculated delta I from this. These extra 3 lines you might ignore because that is the same thing what I am telling you in very shortcut. Okay, that becomes bus 2 voltage. Similarly, when I move to bus number 3 for PQ bus. At PQ bus, what will be given to you? P is given, Q is given. Initial estimate of V3 is given. Then you have to use same equation. No much difference. So it's the same equation. When I substitute in this, I'll be getting. But you should be careful. V2 of 1 comes here. Because it's the previously computed best fit value of bus 2 has to be revised value over here. And V1 is slack bus voltage. No more revision for that. And all these values must be substituted. Then you will be having complex rectangular value. You have to convert it to polar. Then I put a line here, not to go second iteration. Stop here and go to line calculation and slack bus computation. Like this. I just go here. Here, author has used V2, V3, bus 2 generator voltage, bus 3 load voltage, which he used after the computation of second iteration. But now I want only one iteration. Use one iteration, stop it. Like this. Okay, I'll stop here.